Let's talk about the nap in the Netherlands and why it's so important. Have you heard of it? Do you know about it? By nap, you might be thinking of the Spanish siesta. But well, nope. We are not talking about that kind of nap. In the Netherlands, without the nap, we would be flooded. NAP stands for Normaal Amsterdams Peil, which basically means Normaal Amsterdam level. It's like the country's 0 point for measuring height, a reference level for how high or low the land is compared to sea level. Every dike, canal, and bridge in the Netherlands is measured in relation to this NAP. The NAP helps engineers know exactly where the water should and shouldn't be. And it has to do with the rising sea level. And this is how it works. The ocean isn't flat, it moves. Tides change the surface every day, so we take an average of those ups and downs to get mean sea level. We've got two awesome tools, one on the coast, one in space. Tide gauges. These guys sit along shorelines, tracking how high the water goes compared to solid ground. Super precise, super local. Then satellites take it global, firing radar pulses down to the ocean to map sea surface height everywhere on Earth. They send radar signals toward the ocean surface and record the time it takes for them to bounce back. Scientists compare these measurements to a fixed reference point, and the results are incredibly precise, accurate to within 1 to 2 centimeters. Put the two together, and voila! Scientists get both detailed local data and a full global picture of rising seas. Weather, storms, and wind can push water higher or lower for hours or days. Those are short-term changes important for flooding, but different from long-term average. Global sea level rise refers to the average increase in ocean height worldwide. However, local sea level changes can vary due to regional geological factors, such as the rising or sinking of tectonic plates. Over decades and centuries, mean sea level can change. Global sea level rise happens because ice melts and ocean's water warms and expands. That permanently shifts the reference line. Locally, the reference matters even more. If land is sinking, it looks like sea level is rising faster there. If land is rising, relative sea level may fall. So scientists often say relative sea level. That's sea height compared to the ground where you stand. So let's recap. Sea level is a long-term average used as a reference. Short-term changes come from tides and storms, and long-term changes come from climate and land motion. The idea of a reference water level goes back to the 17th century. Amsterdam city engineers started measuring the average high and low tides on the I Bay. This Amsterdam Peil became the national standard and later evolved into NAP, the Normaal Amsterdam level. Engineers connected NAP to a network of thousands of reference points, metal bolts, and markers all across the country. You can even spot some of these markers today on buildings, bridges, and dikes. Alright, but why go through all this effort? Because in a country where water is everywhere, precise height measurements save lives. With NAP, engineers know exactly how high dikes need to be, how deep boulders are, and where flood risks start. In short, NAP is that invisible line that keeps the Netherlands above water. Today, NAP is maintained with cutting-edge technology. Surveyors regularly check thousands of reference points using GPS, lasers, and satellite data. There's even a NAP measurement station in Amsterdam, where the original benchmark is kept under lock and key, deep underground, safe from weather and movement. And thanks to global coordination, NAP now aligns closely with the European Vertical Reference System, ensuring international consistency. Now let's take a look at the NAP indicator I previously found at Gemaal Zeeburg. The reason there is an underground floor below NAP at Gemaal Zeeburg and many other pump stations or Gemalen is functional and hydraulic. Here is how it works. The pumps must sit below the water level they control. For a pump to move water efficiently, its inlets, the suction points, have to be below the lowest water level of the basin or canal it serves. If the pumps were above the water level, they could have sucked water upward, creating air bubbles or cavitation, which reduces efficiency and can damage the machinery. By placing the pump chambers below NAP, the pumps work under positive pressure. That means water naturally flows into them due to gravity, and the pumps just push it upward to the higher side. Gemaal Zeeburg lift water upward from Amsterdam's canals. The Amsterdam Canal System, or Amsterdamse bussen, sits below sea level, usually around minus 0.4 to minus 0.6 meters NAP. The eye and bottom eye, where the Gemaal discharge, are a bit higher, around 0.2 to 0 meters NAP. So, Gemaal Zeeburg's job is to pump water upward from the lower canal level to the higher discharge level. That's why the pump chambers and intake floor are built below NAP, to stay aligned with the water they are draining. The underground floor houses key hydraulic and maintenance systems. Below ground, at Gemaal Zeeburg, you will find intake channels and pump chambers connected directly to the lower canal. Valves, gates, and debris filters, called roosters. Walkways for engineers to inspect and maintain the pumps. Foundations is strong enough to resist the uplift forces from surrounding groundwater. This space is the heart of the Gemaal hydraulic operation. Safety and waterproofing. Even though this basement lies below NAP, it's fully watertight and reinforced. The concrete is designed to withstand hydrostatic pressure, and seals and drainage systems keep it dry enough for maintenance work. In short, the underground floor at Gemaal Zeeburg sits below NAP, so the pumps can work with gravity, drawing water in naturally and lifting it up to a higher discharge level. It's not just smart engineering, it's a fundamental part of Dutch hydraulic design. So yeah, Amsterdam is not only stunning, it's rich in culture, history, and also a rich engineering background. That I love the most. So, if you like this type of content, don't forget to press the thumbs up button, leave me a comment, and share with anybody who might find it interesting. Until the next video, see you soon. Bye!